All right, we're going to tackle exercise 5.2 of Murach's Visual Basic 2015. This is on page 175 of your book. Again, exercise 5.2. And we start by creating a new project. By now, you should have Windows Forms app .NET framework in the Visual Basic language under your recent project templates. So go ahead and click Next. Again, for my class, we call this your last name X or exercise 5.2. If you need to change where you're saving it, go ahead and do that. You want project and solution in the same directory. And the framework, 4.6 or higher is fine. We'll do 4.7. Why not? And hit create. And then we need to create the form, or add the form elements. So we're making the form as seen on page 171. Which is figure 5.10. So I'm going to do that without really talking through all of it. By now you should be pretty comfortable making a form. Remember, when you make your labels, you should name them with the prefix LBL. And don't be stingy with these object names. You have more than enough room to use for the yearly interest rate. Call it LBL, yearly interest rate. So we have number of years. And future value. All right, then I need some text boxes. I have 4 of them. And when you name your text boxes, prefix it with TXT, and then it should be named the same as the label, except obviously the prefix has changed. Okay, future value is going to be read-only because this is where the answer is going basically. And get in the habit when you set read-only to true, set tab stop to false because you're not going to be tabbing into that. Looking at the labels, there are no access keys on the labels. There are access keys on the buttons, which I haven't drawn in yet. But okay, I'm going to take these guys and under, let's see, view toolbars, make sure layout is checked and turned on, and you should see this is what their layout toolbar looks like. So I'm going to select these text boxes. I want to align them to the left, which they already are, and then I want to make vertical spacing equal. So now the space between boxes 3 and 4 is the same between 1 and 2, same between 2 and 3. And then I'm going to align the these labels up to the text box with this pink line, which is not quite the bottom of the box. I think it's the bottom of like the text inside the box. And then I'm going to select these labels, align them to the left, and that looks pretty good right now. I'm going to select everything, move it up to the corner, and now I just need a couple of buttons. Button 2. I have my buttons. I'm gonna put them down here. That looks fine. I'm gonna call this one. So button names are prefixed with BTN, and we have BTN calculate. And the text on that is going to say calculate, and the C as an access key, so put an ampersand before it. And this other one is exit, and put an access key on the X. And the name for that is BTN exit. While we're at it, our form, I'm gonna rename this FRM future value. I like a better name for that. The text, so really what appears up here in the window is future value. When it starts, it's going to start in the center of the screen. The accept button is BTN calculate, and the cancel button is BTN exit. All right, and then we'll just take this form and resize it a little bit. There, that looks really good. And real quick, I'm just going to check my tab index. Really, the only places we're tabbing are these 1, 2, 3, 4, 5. So our tab stop on this is going to be 1. Our tab stop on this, 2. This tab stop is 3. This tab stop is 4. And this tab stop is 5. So those little things make a big difference in your application. All right. Let's see. Oh, and figure 510 says the text align property for each of the labels is middle left. So let's just make sure we have that set. So I selected all the labels, and text align, oh, we want middle left. Not a big change there. And then, yep, tab index, our set focus moves from top to bottom, left to right. So it's going to move basically like you were reading. But because we don't need to have the cursor stop on these labels, it's just going to run down and then left to right. So I'm going to hit save, and then let's run it. You know, it's not really going to do anything, except it should give me a form. And as I hit tab, 1, 2, 3, 4, 5, the tab index works great. None of the buttons do anything because we haven't programmed them yet, but we can still hit the square to get out of that. Okay. That was like the first sentence of step 2. So this is going to be a longer assignment. Generate the event handlers for the 2 click events and add the code for these handlers. The code is in figure 511. This is one of those cases where we're going to use some of the code because I don't expect you to know what the future value formula is. But we should be able to do the exit button without looking at the code in the book. We know that when someone clicks on the exit button, we just do a me.close. All right, that was an easy one. How about that calculate button though? So taking a peek at the code in the book, we have 1, 2, 3, 4, 5, 6 variables that we're going to set. So the first 3 appears, yep, we're just going to read the user's input and then convert it appropriately. So give me some room here. Dim monthly investment. And monthly investment is going to be how much money is the person putting in the bank. So it's like $100. I'm going to convert to a decimal. The text property of txt monthly investment, that object. So we're going to grab what the user put in here, what the user put in, convert it to a decimal, store it back here. We're going to do the same with yearly interest rate. And finally, years. Years is an integer, not a decimal, because it's going to be a whole number. So we're pulling from txt number of years. If you are looking at the book, they called their text box txt years. So just make sure you get that lined up right. Okay, so the next thing we need to know, we know the yearly interest rate as the user entered it. The user would have entered like 8. What we want to do is get a monthly interest rate, which is just the yearly interest rate divided by 12. We're also going to divide it by 100, because if this yearly interest rate, let's say, was 12, I'm just going to make it simple for me, then here it's 1, and then we divide it by 100, it's going to give us 0.01. So this is more like a percentage, right? But when the user enters a value, it's going to be a value like 12 or 12 and a half. And then we need to know how many months. Which is just years times 12. Okay, so far we've just kind of set some variables to line up our calculations. And then we need to hold, we need a variable to hold the future value. And it does not have a value to start with. Okay, we are going to use a for loop. Are we on? Yep, we are still in step 2. But step 2 does say, use a code snippet to start the for loop. So under snippets, we want a code pattern, conditionals and loops, and I need a for next statement. All right, and our index is going to be I. And remember, like an index like I keep saying use variable names that are descriptive, but when you're using a quick counter, just use I, and that's just going to increment by 1 or something like that, and then it's going to go away. So in this case, we're counting from 1 to the number of months. So if there's 1 year, it's going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the future value is going to be equal to the previous future value plus the monthly investment times 1 plus the monthly interest rate. This is that formula that I don't expect you to know, but it kind of makes sense. If we start with, I'm adding this equals 0 here to help this make more sense. Let's pretend that the yearly interest rate is 12. The monthly interest rate would then be 1%. And let's pretend that we're putting in $100 for 1 year. So our months would be equal to 12. What happens here is the future value is now going to be equal to the previous future value, which is 0, plus the monthly investment, which is 100, times 1 plus the monthly interest rate. So it's going to add 1% onto it. So in month 1, we're going to have $101. And then in month 2, we're going to add $100 to that, and then the interest compounds. So we're adding 1%. We're not just adding $101 because you're getting 1% on the previous month's 101. Anyway, this is going to add up your future value. We have this value. We need to put it in our form element, our text input box here, which we call text future value. We're going to put it in there, and we're going to format it as currency. And then we're just going to bring the cursor back to the monthly investment text box. Okay, save it, run it. And they give you some examples here. So we have $100 a month at 12% and 1 for the number of years. When we hit calculate, you should get $1,280.93. If you did, great. If you didn't, go back, review your code. Look at figure 511. Because that's what you should be getting. That's the correct answer. And then it wants us to do things like run it for 1,000 years. And you will see that you get a runtime error. So it's not a build error. Our application built just fine, but when we ran it for 1,000 years, the number just got to be way too big. And in chapter 7, you'll learn about this, but you can see what the future value is. That's a really big number. Eventually, it just overflowed. All right. So it wants us to exit out of this, stop that. All right, step 5 says, in the code editor, set a breakpoint at the for statement. So this is on line 16 by clicking in the margin indicator to the left. So you're going to get that red circle there. This is also shown in figure 5.9. And once you have the breakpoint set, we're going to run the application, 112.1. And we hit the breakpoint. So at this point, the code's right here, or the code is kind of running through. It stopped here because we hit the breakpoint, and you can see that the value of our variables. If you can't see the locals window, that is under Debug, Windows, Locals. Make sure that's turned on. And then it wants us to hit F11 to step through. Now we can see that this line ran, and we're at the next line. But when that line ran, I was incremented to 1. Anytime a local variable changes in between breakpoints, it'll turn red here. So now we can see future value, in that line ran, future value increased to 101. We're at the next, which is going to be tell us to go back to the beginning of the loop, and we did. And I just incremented to 2, hit F11 again, future value goes to 203.01, etc., etc. And then step 8 says you can hit F5 to just let the application run until the next breakpoint, which we don't have a next breakpoint, and it ran just fine. All right, step 9 says take away the breakpoint and put one inside the loop. So now when you hit F5 to run, it's going to stop. It's going to stop inside the loop. When you hit F5, it'll stop every time you are inside the loop. So that's just a difference of, do you put your breakpoint at the beginning of the loop where you can step through a little more granular, or actually inside the loop there. There's just no good way to get out of that loop if you have your breakpoint inside the loop. Okay, that finished running. When you're done, remove the breakpoint. So steps 5 through 10, when you're done, there should be no breakpoints, and really there's no way for me to know whether you did it. So hopefully you'll do that. Breakpoints are going to be useful if your loops get out of control or you're starting to get funny data. You want to be able to use breakpoints to stop your code from running and inspect what's going on. Okay, now we're going to insert a code snippet. I got to remember this shortcut, KX. We want a code pattern. I need a loop, and it's saying I need a do loop. I want to, it just says use a do loop, and really there's 1, 2, 3, 4 different do loops. So I'm going to choose a do while ... loop. And here I'm going to say dim I as integer equal to 0, and do while I is less than months. And in my loop, I need to say I plus equals 1. And so, and maybe I shouldn't use I because it's complaining, because I have this in here already. I'll use j this time. Okay. So I'm doing the same thing as this for loop. I'm starting at 0 and going to months. You could also start at 1 and go j is less than or equal to months. Maybe that makes more sense from a logic standpoint. Says finish the do loop. Well, it's really just that same statement. Future value equals future value plus the monthly investment times 1 plus the monthly interest rate. So if I take this part and comment it out, sorry, not, I still need future value declared. So I have future value declared as 0. My loop is now j is an integer, starts at 1. It goes from 1 until we hit the number of months. Calculate the future value. Make sure you increment. In your for loop, the incrementing happened for you automatically. If you don't increment in your do loop, it'll run forever. I hit F5, and I get the same value, but it's being run in a do loop. Okay, that was step 11. Step 12, add an if statement and an exit statement to the do loop that exits from the loop when the future value is greater than 1,000. All right, add an if statement and an exit statement to the do loop that exits from the loop when the future value is greater than 1,000. So we have a future value is greater than 1,000, then exit do. And that's going to exit this do loop. Test this, so we're going to run it. So as soon as the future value gets to be over 1,000, which in this case it was the step of future value hitting 1,056, it exits the loop. It stops running this loop completely. And then what we want to do is change the exit statement to a continue statement. I would recommend commenting this so we can see what's happening. So the loop will continue even though future value is greater than 0. In other words, the loop will continue to completion because the if statement doesn't do anything. Then test this change. Note, however, if the if statement precedes the statement that increments the counter, which mine does, it'll result in an infinite loop. So I'm going to take my incrementing the counter and move it up. F5, so this is going to do absolutely nothing. So you might think, like, why would you want to use a continue do? Well, instead of saying, like, if future value is greater than 1,000, you could say if I mod 2 is equal to 0. This should be, sorry, if j mod 2 is equal to 0. There we go. If j mod 2 is equal to 0. So really on even months, we don't do anything. But on odd months, we add to the future value. So now when I run this, the future value is a lot less because it's only being run during odd months. During even months, our continue do says, go back to the top. All right, but what this really said before was, what did it say? If future value is greater than 1,000. And this calculation was really right here. Okay, So that's what your code should kind of look like right now. And when you're done experimenting, I think we're done. Save it. Test it one more time. Make sure that during your experimentation you didn't screw anything up. Perfect. That's it. Save it, zip it, send it in.